Dear students, the question number 8 from chapter number 3, the question states that a ball of mass 0.4 kg is dropped on the floor from a height of 1.8 meter. The ball rebounds straight upward to a height of 0.8 meter. What is the magnitude and the direction of the impulse applied to the ball by the floor? Uh, let's draw the situation, what is happening. Uh, Let it be a ball and it is dropped from some height, and this height is given, it is 1.8 meter, and here it strikes the ground and then it rebounds, it moves again upward to a certain height, and this height is also given, it rebounds to a height of 0.8 meter. And what we have to do, we will have to calculate the impulse, okay, which is applied to the ball by the floor. We will have to calculate this one. To calculate the impulse, we know that the formula to calculate the impulse is I is equal to m multiplied by delta v. Here delta v is the change in velocity. So we will see here how much the velocity has been changed when it strikes the ground here, and then when the ball moves the upward, how much was the change in velocity. If we multiply that change in velocity with mass, we will get the impulse I. For this, first of all, we consider the downward motion. Since the ball was dropped, so initially it was at rest, so Vi was 0. And since it is moving downward, the value of G gravitational acceleration is positive 10 ms minus 2, and the speed with which it strikes the ground, let it will be Vf here. Here this is the speed with which it will strike the ground, we will have to calculate. And here it was initially in our hand, so it was about to drop, its speed was 0. So to calculate the final speed, we will use the third equation of motion, which is 2gh is equal to Vf square minus Vi square. Now putting the values here, 2 multiplied by g, the value of g is 10, and the value of height is 1.8 meter. We had written here 1.8 meter, it was also given. Then it was dropped from a height of 1.8 meter. And the final velocity we will have to calculate, and the initially it was at rest, so initial velocity was 0. Multiplying 1.8 into 2 and 10, we will get 36, and here we will have Vf squared, taking square root on both sides, we will have final velocity with which the ball strikes the ground as 6 meters per second. Now we will consider the upward motion. Upward motion, I write here upward motion after striking the ground. Initially, when it strikes the ground, its speed, when it left the ground, let its speed be Vi, which we will have to calculate or to find. And since when it reaches at the highest point, its velocity becomes 0, so let its Vf in this case is 0. So I write here Vf as 0. Since the ball is moving upward, the value of G will be negative 10 ms minus 2, and the height it reaches is this 0.8 meter. So I write height as 0.8 meter. Now putting these values again in third equation of motion, we will get 2gh is equal to vf squared minus vi squared. Now the value of g is negative 10 and the height is 0.8 and vf is 0 and vi we will have to calculate it is squared. So multiplying this it will be negative 16 which is equal to negative vi square. Cancelling negative on both sides and taking the square root, we will get vi as 4 meter per second. 4 meter per second. It means that when the ball bounces upward, its initial speed was 4 meter per second. So to calculate impulse, we will have to calculate how much there was change in speed. Delta V, we will have to calculate change in speed. If I say this Vf with which it strikes the ground as Vi, which was 6, which we calculated here, not Vi but V1, sorry, and I take this speed as V2, then the change in speed will be equal to V1 minus V2. But if we are taking the downward motion as positive, for example, when the ball was moving downward, if we take its direction as positive, then the upward motion will be as negative. If we take the downward motion as positive, then the upward motion will be considered as negative. Since velocity is a vector quantity, so we will also consider their signs. For example, if the downward motion the speed was 6 minus the upward motion the speed was 4, but since it was opposite in direction to the first, the direction of speed, so we'll take its negative sign. 6 and minus minus plus 4, it will give us 10. So the change in speed, the speed which was changed was 10 meter per second. So to calculate the impulse, we will multiply mass with change in speed. Since the mass of the ball was 0.4 kg, we will multiply this 0.4 with change in speed which is 10. So the impulse is 4 and this is Newton into second, or we can write it as kgms minus 1. I repeat it again. After reading the statement, we know that we have to calculate the impulse, and the formula for the calculation impulse is mass times the change in velocity. So first of all, we will find the change in velocity delta V. For this, we must know the speed with which it strikes the ground. Let initially it was 0, and the speed which it strikes the ground is Vf. Using the third equation of motion, we calculated Vf as 6 meter per second. Now when it rebounds, we take the upward motion and let its speed when it leaves the ground is 0 Vi, and at the highest point its speed is 0 and g is negative 10, and the highest height which it reaches is 0.8 meter. Again calculating, we get the Vi as 4 meter per second. So the change in speed can be calculated as the difference of these two speeds. So 6 minus minus 4, it will be 10. So the change in speed will be 10 meter per second. So the impulse is mass times the change in speed. 0.4 times 10 will give us 4 Newton second. Thank you very much for watching this video. See you in next lesson.